We're good.
We are good.
Okay.
Yes. If Michael Hernandez was here, he'd say that's fair.
Fair enough.
Yeah. Okay, so it's my pleasure to present Zach, who's going to present Third Eyesight. It's pretty cool.
All right, so as Perry said, my name is Zach Drobenko. I'm a senior here. This is my senior thesis, Third Eyesight. So the problem that I was presented was, this is sort of a personal problem. I have two friends at home who are visually impaired, 70 to 80% visually impaired, and it's really hard for me to watch them not know who they're talking to, even though they'll know, but their brain just doesn't register who they're talking to, even with audio. So the problem is if you're visually impaired, you don't know who you're talking to. So my solution was to create a wearable device that will allow visually impaired people to be able to recognize who is in front of them with the click of a button using facial recognition through OpenZV and using hardware with the Raspberry Pi, whether it be on the brim of a hat, you attach it to your shirt. But this is a very rough prototype, so we'll get to that later. So here's my layout. So the most important part is the hardware, which is the Raspberry Pi and the camera module that is attached to it. When a button is pressed, facial detection goes on, and then facial recognition goes on, and with that we can access a Firebase, which is a Firebase specifically for Raspberry Pi, and then we will be able to text-to-speech through an earpiece once that button is pressed. All right, so the hardware was probably the main component to all of this coming together. The Raspberry Pi 3 is what I used with a camera module, which is a V2 8 megapixel 1080p pixels. So that's basically the main component, the main device that I would use to recognize people's faces. With future use, I would like to implement an external battery and more buttons to that. But this right here is basically the rough prototype of what I am doing. So we get into software now, which is OpenCV. So OpenCV is probably the most important part of the whole software. OpenCV is an open source computer vision and machine learning library, which contains implementation of a large number of vision algorithms, whether it be for still images or a video stream or movies or MP4s. And what I used for the facial recognition was the hair cascade. I specifically used the hair cascade default frontal face, which is an XML file which only recognizes people's face based on front, not on side for profiling. And then so with that, the latest version of OpenCV I installed with Python 3. A problem with OpenCV and Raspberry Pi that I should have seen was I installed OpenCV straight onto the Raspberry Pi, which the build took about 8 hours to build, which what the?
Okay, now stop broadcasting.
Sorry.
Okay, we're good. So, what is going on?
Okay, I'm gonna sit down now.
What is going on? I'll wait for you to sit down.
Okay.
All right, so when downloading and installing OpenCV onto the Raspberry Pi, it took about 8 hours, so I realized that I would need to create a virtual environment for the Raspberry Pi to run OpenCV off of, and that's what I was doing before I started presenting, was getting that Raspberry Pi into that virtual environment to work on OpenCV. So the next part of the software is implementing the facial recognition, or facial detection. So instead of capturing images with the Pi, I decided to turn the camera into more of a webcam. so it'd be a video stream. I wrote code using the OpenCV hair cascades to make a 128 vector that would quantify each person's face on the stream. So what it does is it will detect motion of the person's face using the hair cascades default frontal face XML file, which looks for eyes, nose, and mouth in a person's face, and then we'll put a box around that person's face and track that person's face within the video stream, which is what it did. And then so training the Pi. So first I wanted to create a data set locally to test for the facial recognition. So training the Pi is probably the last step for facial recognition. The Raspberry Pi needs to learn that it's that person's face with that person's name. So the Pi camera module would take 30 photos and store them in a data set. They would be all grayscale. The Pi camera module would turn the color photos into grayscale and basically run its facial training algorithm on itself to basically compare that user's face to that name and mold them together. So another big component was Firebase, which is a little bit different than Firebase. Actually, my classmate Andrew suggested I use Firebase because he used Firebase. It's a third-party API that allows connection between Python code and Firebase's real-time database. I realized that Raspberry Pis in Python, you can use SQLite 3's database, but I'd rather use the real-time database to store those images. So I would send Firebase the 30 images to store with that person's name. So we would pull from Firebase when we would do the text-to-speech. So after the training the Pi, that's when we would send over the images to Firebase for the real-time database with one argument, which is the person's name. And in Firebase, they store the photo as blobs rather than binary. So that was nice from when we would pull. So the last component of the software was the button, which is GPIO. I connected the button to pin 4 using 2 resistors and 2 wires. I'm really not good at soldering things, so it's pretty rough, but I connected the buttons to them. When the button is pressed, system calls the facial recognition function to run on a loop, so therefore you can press the button as many times as you want for however long you wanted to, and it would recognize people's faces. Every time you press the button, they would recognize someone's face and tell you in your ear who that is. All right, so the last part is, that's a terrible photo of me. The last part is the facial recognition. It runs through all the photos in the database and finds recognizable features to the person in front of the camera and spits out a name. So this was the last component to my Third Eye site, which it would just put the box around your face, like in facial detection, and it would print out the percentage of the face, percentage of recognizable features to your original face that is stored in the data set, and it would print out your name. Finally, we would do text to audio. It would just output the name string via speech, uses PYTTSX and Google Voice, and what it does is says hello and then person's name. All right, and now I need my demo. Michael, yes. All right.
Hello, everyone.
Oh my lord. All right. it not on? The green light.
Maybe try and plug in.
It was literally working 2 seconds ago. It was literally working 2 seconds ago. Sorry about this, everyone.
Is the Pi working, just not
Yeah,
displaying?
it's working. The keyboard's all lit up. It was working 2 seconds ago when I was putting in the virtual
Yeah,
environment.
so yeah, things are starting to go fritzy
Okay.
with the display.
Hmm.
Could you demo without actually displaying anything
Mm-mm.
on the?
I would have to create, so I can't demo without actually putting the display up.
Okay, one thing we haven't tried is we haven't tried power cycling the display. Now that will take a few minutes though, because the projector will want to cool off before we can turn it back
You want me
on.
to do my reflection?
Sure.
Reflection and then.
Yeah, yeah. Now, we've all seen his project work. So,
Yeah.
This is a projector issue because
Yeah.
just before this, we were testing it, so
all right.
technology, right?
I'm a little skeptical, I've never seen it work.
Yeah.
Oh no.
James hasn't seen it work.
Jeans and I are.
It worked as of 240.
Theoretically, it works.
Okay, so now you're still hooked
Recognize
up.
Sky, Michael, Marissa,
Yeah, we got
and
here
Perry.
early. They added my face to the database. and
Yeah.
recognized it right away.
It would also work if we had another external monitor. I bet there's another monitor on this floor that you can snag, right?
I just feel bad because I want to show people and
All
show
right.
that it works. You know?
Yeah, so we're not getting it, yeah. So do you want to show your reflection then?
Yeah, I can show my reflection.
Okay.
It's fine. Just pull it out. Yeah.
All right.
All right. All right.
Okay, I'll move you to it.
So I have no idea why it's. I think it's just a display with the HDMI on the projector, but it was working before the first presentation.
Yeah, about an hour ago.
Yeah, it was working before the first presentation. So reflection. What I learned is I learned to be patient with myself. I learned that it's not going to come overnight. You know, it's baby steps, like Alex said. You know, they're milestones. You create milestones that you want to finish with. I learned to step away from the project when I was flustered. I would get really frustrated with myself with the Raspberry Pi as well. The hardware is not an easy thing to work with. And take some time to myself. Go do something else, and maybe in that time that you take to yourself, you find out you find a solution to a problem that you had. I learned that everything didn't need to be done in one day. It's a process. You have a whole year to do it. You have the learning phases of it, the research phase, and then the development phase. But most importantly, I learned that I can do it. No matter how hard it is, if you put your mind to it, you can do it. Younger guys, find a project that you love, because you will hate it. Like Perry said, you will hate it. But find something that you're passionate about, and something that makes you really excited to develop something. That's my biggest advice to you guys. Find something that you're passionate about. And then questions.
Okay. Yeah.
Could this have worked on a mobile phone? In other words, do you think you could use the OpenCV and all the things you're using on a mobile phone?
Mm-hmm. Yes, it could have.
Because I'm picturing like person just
Yeah.
having the camera exposed and the.
Yeah, it could been used on a mobile phone. What I wanted to do further actually Perry suggested this, was I would have to manually input the data, so I would have to run the function for capturing all of those faces, and the first argument would be, say, like Mark. I would have to send that over to Firebase. I actually wanted to, in a future date, put a microphone on there for voice recognition, where it would be, I would run that function, press a button, and then you would say your name, and then it would just store your photos and stuff like
Yeah, I was
that.
gonna ask that next.
Yeah.
Is there a equivalent, maybe you don't know, maybe, like an audio recognition framework like CV? Are you aware of anything
I
else?
think Google has one.
I'm not sure.
I'm not sure, but
Yeah. Well, it is, OpenCV runs great.
Oh, yeah.
On phones.
yeah,
It's amazing.
I had to research a lot about OpenCV. It is a huge library. It is a huge library and very, very, very useful for image processing.
Can I ask why you chose the Pi then, instead of the mobile app?
Because I'd never worked with hardware before, so I wanted to teach myself, pin numbers and all of that, and connecting the camera to that and making sure everything works. So I wanted to teach myself that. So,
Would you do it again?
yeah, I would do it again. A little bit different. I would have created an image of OpenCV, so I don't have to wait 8 hours for the build file to run.
Yeah.
So.
While I walk up there, why not plug the HDMI in? We'll give it one more chance.
We'll give it one more chance. All right.
Yeah.
And the microphone broke.
All right.
Is that it? Unplug it, plug in the HDMI, then replug the Raspberry Pi.
Okay.
Yeah, he's got it that when it powers on, it boots right into the application.
Nope. Damn it. That's frustrating.
Well, you have witnesses. Okay.
Yeah.
Do you want to get set up? Are you next?
No.
Who's next?